An e-scooter travels at a constant velocity of 3 meters per second and passes a stationary sprinter. 2 seconds after the scooter passes him, he starts accelerating, the sprinter does, in other words, at a rate of 1 meter per second per second. After how long does the sprinter overtake the scooter? So you can pause the video, have a crack at this, but you're going to need to look a bit harder than just plugging numbers in and hoping for the best. So see how you get on, pause the video. And unpause it now, I guess. Here's the solution. So for the e-scooter, we've got displacement equals velocity times time, and that will give us the displacement of 3t. With the sprinter, because they're accelerating, we're going to need an expression for a in there. And to make things a little bit easier, the sprinter starts at 0 meters per second. They're at rest, and then they start. The final time in which they meet the e-scooter will be t minus 2, because the time will be the same for both of them. So that's what we're trying to solve for. Handily, the first part of the equation cancels out, leaving us with s equals half times 1 times t minus 2 squared. The square might give you a hint of the direction this is going mathematically. So we're going to make the equations equivalent for s, and this will give us 3t equals a half times 1 times t minus 2 squared. My first thought was I'm going to multiply a half by 1 because that's easy, and then I'm going to multiply both sides by 2, and this gave me 6t, and then I expanded the square, and I was like, this is beginning to look a little bit like a quadratic, and I can certainly get it there by applying the FOIL method. So I went for 6t is equal to the first expression, t times t squared. Then the outer expressions there, t times minus 2. Then the inner ones, minus 2 times t, there's another minus 2t. And then the last two expressions, minus 2 times minus 2, giving us plus 4. So far, so good. With that, I thought, you know what, I can use the quadratic equation here if I just take this a little bit further, get the 6t over the other side, and all of a sudden it looks like a quadratic. We've got t squared minus 10t plus 4. So firing all of that in, so a being 1, b being minus 10, and c being plus 4, we can put that into the quadratic equation as follows. Giving us t equals 10 plus minus the square root of 86 over 2. And then we just need to simply look at both versions of the equation, the plus and the minus version. Here's our two versions of the equation. We just have to kind of come to a conclusion in which answer makes sense. So the minus one gives us a time of 0.4 seconds. Now, after that amount of time, the sprinter will only be moving at 0.4 meters per second, assuming their acceleration is constant. So there's no way that is the correct answer. It's got to be 9.6 seconds, the correct answer. Thanks.